if sum of this series 1 square into 15c1 plus 2 square into 15c2 and so on up to 15 square into 15c15, this is 2 raised to m, 3 raised to n, and then 5 raised to k, where m and n and k, these three are natural numbers. So then we have to find the value of m plus n plus k. Now, there are multiple ways of solving such type of problems. Before we attempt this problem, there is one important formula that you should know. NCR, this you can write as n by r and this multiplied by n minus 1 cr minus 1. We'll solve this problem using sigma notation. So for that, we need this formula. NCR is n by r and then n minus 1 cr minus 1. So here let us say this sum on left hand side, this is S. So using sigma notation, you can say that this sum will be summation. In first term, we have 1 square into 15c1. Second term is 2 square into 15c2, right? And so on. So clearly you can see that rth term will be r square and this multiplied by 15cr, and the value of r, this will start from 1, right? For first term we have c1, then we have c2, c3 up to 15. So r will be from 1 to 15, right? This is the sum that we have to calculate. Now here our aim will be to get rid of this variable r. Once I get rid of this r or r square, then we have a standard formula for finding this sum, right? I mean, sum of first n binomial coefficient nc0 plus nc1 up to ncn, this is 2 raised to n. So that formula we can use, but for that first we need to remove this r square from here. And for removing r square, we are going to use this result, that ncr n by r n minus 1 cr minus 1. That means you can write this sum as r square and this multiplied by 15 cr, so that is 15 by r, and this multiplied by 14 cr minus 1, right? N by r, and then just decrease both of these by 1. So 15 by r into 14 cr minus 1. The range for r is from 1 to 15, right? In final step, we'll consider this one. For all of these, sigma r is least value of r is 1, right? R can take all the values starting from 1 up to 15. Now 1 r you can cancel. 15 is constant that you can take outside, and now we are left with r into 14 c r minus 1. Now the problem is that if I use the formula in next step, in denominator you will get r minus 1, right? This thing you can write as 14 by r minus 1 and then 13c r minus 2, right? But so in denominator you can create r minus 1, but here we have r. So now for that what we can do is we can write this as r minus 1 plus 1 and we'll create two sum from here, right? One will create r minus 1 into this term and the other one will be 1 into this term, so that we can get rid of that variable r, because once I remove that one, then we have a standard formula for that. So this is one again very important step. R minus 1, this is one term, and plus 1, this will be another one. So now we can write this as 15 sigma r minus 1, this multiplied by 14 cr minus 1, and this you can write as 14 by r minus 1 and then 13 cr minus 2, and the other term will be 15, you can keep common, and then we have 1 into this term, so that means sigma 14 cr minus 1. And now you can see this r minus 1 also we can cancel, so ultimately we have 15 into 14 into sigma 13 cr minus 2, and the other term will be 15 into sigma 14 cr minus 1. Now we can write the sum of this series, right? This series will become, remember r is starting from 1 up to 15, right? Here the limit for r, this will start from 1 to 15. Here also the limit for r is from 1 to 15. Now if you take 1, then obviously you will get negative minus 1 here, which is meaningless. So we'll start from 2. At 1 we are getting meaningless term. NCR is defined only when n and r, both of them positive integer or 0, right? It cannot be negative number or fraction. So for this one, although the limit is from 1 to 15, but at 1 we are not getting anything, right? So we'll start from 2. Now, if you substitute 2 here, you will get 13C0, right? If I substitute 3 here, then we'll get 13C1, and this will continue up to 13C13. And I mean, you must be familiar with this result, but again, I'll write this one, that if I have NC0 plus NC1 plus NC2 up to NCN, right? Sum of all binomial coefficients starting from 0 up to n, this is 2 raised to n. So that means here, this first sum, this you can write as 15 into 14, and then this series will start from 13C0 up to 13C13, so that will be 2 raised to 13. And similarly, the second one will be 15 into, and then again, if you take R as 1, then it becomes 14C0. Then at 2, you will get 14C1. So here we have 14C0, 14C1 up to 14C14. So this is nothing but 2 raised to 14. And now you can take 2 raised to, in fact, from here you can take 15 into 2 raised to 13 common, right? In fact, 2 raised to 14 you can take common, 15 we can take common, and then 2 raised to 14. So this becomes 7, and from here you will get 1, right? So finally this will become, this is 8. So 14 plus another 3, that is 2 raised to 17, and then 15 one can write as 3 into 5. So this is the sum that we are getting finally. Now we need to compare this sum with 2 raised to m, 3 raised to n, and 5 raised to k. So clearly you can see that m will be 17, right? Here the value of m, this is 17, n is 1, and k is also 1. So that means this sum will become 19, right? So the correct answer for this problem will be second option. So I mean, these type of problems, they are not difficult. First you need to write using this sigma notation, and then we have to get rid of this r or r square. So first we have written 15 CR as 15 by r, when r will cancel, and in next step you will get r minus 1, right? Because here we have 14 CR minus 1. If we apply the same formula, we'll create r minus 1 here, and that means we need to write r minus 1 plus 1, and now again separate and create two summation. Finally, the sum was 2 raised to 17 into 3 into 5, and therefore m plus n plus k, this will be 19, and that is the correct answer for this problem.